Welcome to Brain Vision.
So in this problem, we have 1 liter of liquid nitrogen in a 1 by 1 by 2 meter room. And we want to figure out how much air in that room is displaced when this amount of nitrogen evaporates. And so to do that, we want to find the volume of the nitrogen and the volume of the room, and then just divide the volume of nitrogen by the volume of the room to get what percentage of that is now nitrogen. And so the first thing we want to do is convert this 1 liter of liquid nitrogen into number of moles so that we can use the ideal gas law to find the volume of nitrogen gas. And so the first conversion here is just converting 1 liter into milliliters. So 1,000 milliliters in 1 liter. Then we want to multiply by the density given, which is 0.807 grams per milliliter. And now that we have grams, milliliters have canceled and liters have canceled, we can divide by the molar mass of N2, which is 28.0 grams per mole. And so now our final answer will be in moles, which is equal to 28.82 moles. So now we want to use the ideal gas law, and so I'll go to a new page here. So PV equals nRT, and we want to rearrange to solve for volume. So volume equals nRT over P. Our N we just calculated to be 28.82 moles. Our R value is 0.082057 liters. Liter atmosphere per mole Kelvin. Then our T is given as 25 degrees Celsius, which we can add the conversion factor of 273.15 to this to get our temperature in Kelvin, 298.15 Kelvin. And then our pressure is given as 1.0 atmospheres. And so when we plug all these values in, we get a volume of 705.125 liters. So this is now the volume of nitrogen gas. And so now we want to find the volume of the room. And so the volume of the room is 1 times 1 times 2. So 2, and that's meters squared. Since each of, or meters cubed, since each of these values is meters, 1 meter by 1 meter by 2 meters. And now we can convert this 2 meters cubed into liters by the conversion that there is 1,000 liters in 1 meter cubed. And so our meters cubed cancel, and we end up with 2,000 liters. So now to find the percent of N2, we take our volume of N2, which is 705.125 liters, divide that by our total volume of the room, 2,000 liters, and multiply by 100 to get it into a percent. And we find that we have 35.26% of the air in that room is displaced by this evaporating nitrogen.